Hey guys, this is section 2.2 notes. The title of this is deductive reasoning. We have a little example here on top. You don't need to write it down, just listen and read it as I read it to you. It's kind of based on that car example that we used on the first notes, where if you assumed that your car is started every day since you bought it, you're going to assume that it's going to start again tomorrow. That's inductive reasoning. Now, what happens if one morning your car does not start? Your job is to look for a reason as to why it didn't start. What could have caused the problem? You scan the instrument panel and you notice that the headlight switch is in the on position. The car's lights were left on all night and the battery is dead. Linking the headlight switch with the car's failure to start is an example of deductive reasoning. When you link the statements together, when you use true statements to make a conclusion, that's called deductive reasoning. Not using patterns, not using what happened prior, only using facts. When you use facts to make conclusions, you're using deductive reasoning. So you might want to write something like, deductive reasoning is using facts to make conclusions. Using facts to make conclusions is what we would call deductive reasoning. Okay, so you might want to write that part down. I wouldn't write this whole paragraph up here. You might want to write down what to deduce means. To deduce was where we get the word deductive from. Deduce means to reason from known facts. In other words, make your conclusions based on facts only. Deduction is using facts. Okay, when you reason deductively, you reach a conclusion using logic, using what has to be true, what must be true. You're proving something. So when you're using logic, you're proving something to be true. So when you're using logic, you're proving that something is going to be true. It's a proving. You're proving it. All right, down here, you may not want to write all this down. This is just a kind of example from our car example again. What you're doing is starting with a statement that's true, and you're showing that other statements logically follow from them. Please follow along with this. This is important stuff. Look at the following based on the car example. Okay, like I said, you can look at it. Just think about it though. For a car to start, its battery must have energy. That's a logical conclusion. If the car is going to start, the battery has to have energy in order to start the car. That's a true statement. That is a fact. Now, from that fact, we can also say that car headlights left on all night will drain the energy from the battery. So if you leave the headlights on, a fact is that the battery is going to get drained. It's happened to me before, so I know it's true. And then the last one we could put down is that when a headlight switch is on, the headlights are also on. That's a fact. If you have the headlight switch on, the headlights are on for your car. That's a fact. So all of these statements will lead us to the fact that the car will not start. So if we look at these three statements, put them together, for the car to start, the battery must have energy. If you leave the headlights on all night, it'll drain the energy from the battery. When the headlight switch is on, the headlights are also on. If we use all these three statements, what it leads us to believe is that if the headlights are on all night, then the car will not start. That's what we can deduce from those facts. If the headlights are on all night, then the car will not start. So based on the facts that I just read you, if the headlights are on all night, the car will not start. That is called a conditional statement. The condition here is that the headlights are left on all night. And the conclusion is that the car will not start then. The conditional statement has the word if and the word then. So you're going to see an if and you're going to see a then. Conditional statements have those two words in it. A conditional statement has to have two parts, hypothesis and conclusion. When you write a conditional statement in if-then form, the phrase that follows if is the hypothesis. The phrase that follows then is the conclusion. So you're looking for the if statement. That would be our hypothesis. If this happens, that's the hypothesis. You're going to look for what follows the then, and that's your conclusion. If then statement. So here's an example of an if then statement. If 2 points lie on the same line, and that's our hypothesis. If they lie on the same line, then they are collinear. That's the conclusion. So the phrase that follows the if is our hypothesis. The phrase that follows the then is the conclusion. Again, you can pause at any time if you get it copied. Here's some examples. We want to write a conditional statement for each one. So let's look at it. You can add equal quantities to each side of an equation, and the equation is still balanced. We need to change that to have an if and a then in it. So we need to start it with if. If you add equal quantities to each side of an equation, comma, then what happens? Then the equation is still balanced. Okay, so if you add equal quantities to each side, then the equation is still balanced. So it's, the statement here was you can add equal quantities. It's a fact. They're telling you a fact. You can change that fact to a conditional statement, to an if-then statement. If you add equal quantities to each side, then it will be balanced. All police officers are government employees. Pause the video, see if you can write it yourself before I show you. What you should have written is if someone or if somebody is a police officer, then they are government employees. So if someone's a police officer, then they are government employees. All police officers are government employees. If someone's a police officer, then they're a government employee. Okay, try the next one. Pause the video, see if you can write it down yourself. It helps you to do it on your own. I know you'd rather just wait for me to do it for you, but it really helps if you try it on your own. It gets you thinking so that you're more prepared for class. So try to pause the video and do it on your own. Okay, an angle is formed by two rays and a common endpoint. So if it's an angle, then it has two rays and an endpoint. And this is not the only ones. You could use other ones. You could say something like, if there are two rays with a common endpoint, then it's an angle. You could do it the other way too. Try letter D. Letter D says the measures of congruent segments are equal. So if segments are congruent, then their measures are equal. Remember the difference between congruent and equal. Congruent means the shapes are identical. They could land on top of each other. Equal means the measures are equal, means the numbers are equal. The number of the measurement are equal. So there's a couple of examples for you. Write those down. Let's look at this page. Let's check out this. Start here for a second. Okay, it says in the diagram, angle 1 and angle 2 are vertical angles. Okay, so let's look at the diagram over here. Angle 1 and angle 2 are vertical angles. Okay, angle 1 and angle 3 are supplementary. That's true because they're straight lines. Remember, straight line, two together make supplementary. And angles 2 and 3 are supplementary. Those 2 and 3 also make the straight line here. Thus, each of the following statements is a true statement. So I would probably get this example on your paper. It's a good kind of example of a little step in the direction of a proof that we're going to be using later. But these are true statements. Angle 1 plus angle 3 is 180. That's true because we know they make a straight line. We know they're supplementary. So they have to add up to 180. That's the definition of supplementary. Here's another true statement. Angle 2 plus angle 3 is 180. If I add 2 plus 3 together, that also equals 180. That's the same exact reason they're supplementary angles. supplementary angles add up to 180, and it tells us that they're supplementary right here. The next true statement that we can put down is that 1 plus 3 is the same as 2 plus 3. Those two both add up to 180, so they have to equal each other. So in other words, this piece equals 180, and this piece also equals 180, so they have to equal each other. That's just substitution. Take out the 180, put in the 2 plus 3. The next true statement that you could put is that angle 1 equals angle 2. The measure of 1 equals the measure of 2. Basically, what I could do there is I could subtract angle 3 from both sides. I can subtract the measure of angle 3 from both sides. So if I subtracted angle 3 from both sides, then basically what happens is that these cancel out and these cancel out, and you're left with angle 1 equals angle 2, which is just subtraction property. Basically, this is algebra 1. Most of this is algebra 1 stuff, just subtracting on both sides. Angle 1 would equal angle 2. And then you would, if the two measures are equal, that means the two angles would be identical to each other. The one would fit on top of the other, so they would be congruent. And actually, this should be a little congruent squiggly line on top of this thing. So let me put that in there for you. This little squiggly should be there. So this squiggly goes right on top. So that's the congruent symbol. Angle 1 is congruent to angle 2. The definition of congruence is that their measures are equal. So all of this right here, this whole thing, just proved that vertical angles are congruent. It proved that angle 1 is congruent to angle 2 because we started with true statements. These are all true statements, and they're true because of these reasons over here. The true statements led us to this bottom one right here. This bottom statement is telling us that angle 1 is congruent to angle 2, therefore vertical angles are congruent, and we just made up the vertical angle theorem. Once you prove something, it becomes a theorem. Theorems are proven. Vertical angles are congruent. And that's it for notes, but there's one more thing I want you to read. You don't have to write it down, so don't panic. I do want you to see this paragraph. It's a good paragraph. In geometry, you will use deductive reasoning to prove theorems and solve problems. We do that all the time in our class. In the workplace, you will use deductive reasoning to solve problems and make sound decisions. Doctors, lawyers, engineers, carpenters, auto mechanics, and telecommunications technicians use deductive reasoning daily to make decisions, not just them. Every single kind of jobs can use deductive reasoning. Deductive reasoning is an essential part of any profession you choose. All right, see you guys tomorrow.